Good afternoon, everyone. So today we are going to discuss the mock PRMO / KVPY paper that was held this last Sunday. Right, so I'm not going to discuss each question in detail. I will just be discussing the basic points of it. So I'm leaving the calculation part up to you. Right, and obviously the question paper and answer key will be in the description box, so you can check the answer from there. Right, now the first question. Write the number of positive divisors of 1200 including 1 and 1200 that are perfect squares, right? The divisors which are perfect squares, right? Now since I need to talk about divisors, so maybe I should go to the prime factorization of 1200. 1200 is nothing but 12, which is 2 square into 3, into 100, whose prime factorization would be 2 square into 5 square. Right, so ultimately this becomes 2 raised to the 4 into 3 into 5 square. Now, I want the divisors that are perfect squares, right? That means if I want to write the divisors, the power of any prime factor has to be even, right? So let me see. Obviously, the first perfect square, which is the divisor, that will be 1. So don't forget that, 1. The next would be 2 square, as you can see, then 2 raised to the 4. Right? Obviously, 3 will not be included, the power is odd. And then we can take 5 square. Right? Then we can take the combination of the 2 prime factors. So I can take 2 square from here and 5 square from here. Then 2 raised to the 4, even power of 2, and 5 square here. Right? So as you can see that there are 6 prime divisors which are perfect squares. Not prime. Divisors that are perfect squares. So 6, or you should write 0, 6, which is the answer. Right? Moving on to the question number 2. He says this number has exactly 4 prime factors. Right? And he says write the second smallest prime factor. Now, one way is obviously I can check the divisibility by prime factors and go on and then stumble upon to the second smallest prime factor. That is one of the way, which is a very good way that you can adopt. But what I want to highlight is this number is really nice, right? Because I can write this number as 27 into, how many zeros are there? So 10 raised to the 6 plus 1, right? Now divisibility comes from factorization, right? Now I have written this number in this form. Why? Because I can easily factorize this, right? I can write this quantity as 3 into 10 square whole cube plus 1 I can write as 1 cube. Now you can see this is nothing but of the form a cube plus b cube. That means the factorization will be a plus b into a square minus ab plus b square. Right? Through that factorization, I am able to find the second smallest prime factor. Right? The answer turns out to be 43. Alright, now on to the third question. Now he says let PQR be real numbers such that 6P plus 4Q minus 7R is equal to 18. 7P minus 18Q plus 6R equal to 4. As in these two equations are given. You need to write the value of this expression. P square minus 4Q square plus R square. Now if I look at the expression, obviously square quantities are getting involved. That means somehow I need to square this. Right? Because in order to get P square, I will have to square this quantity. But if I look at these two equations, let me see. Now, as I can see, the coefficients are somewhat similar. Right? Here the coefficient is 6, here the coefficient is minus 7. Here the coefficient is 7 and here the coefficient is 6. That means coefficient of P and R have been sort of interchanged. Negative sign, but we can deal with that. It's okay. Right? And I can see coefficient of Q here is 4 and the constant term is 18. Here the coefficient of Q is minus 18 and the constant term is 4. That means coefficient of Q and the constant term has somewhat interchanged. Right? So maybe I can make use of this. Let's see. So I would want to keep these two quantities together, 6P minus 7R. And I will keep these two quantities together. So I will transpose 4Q to that side. So this is 18 minus 4Q. Same thing I'll do here. So I'll get 7P plus 6R is equal to 4 plus 18Q. Right? Now, when I look at these two equations, I know, remember that I ultimately need to square it. Right? So I can square this quantity. Or maybe I can square this quantity as well. And if you can notice, if I square this quantity, the minus 2ab term, and if I square this quantity, the plus 2ab term, minus 2ab plus 2ab. Obviously, if I square these two and add them up, squaring and adding, the PR term will get cancelled. Here, obviously, the Q term will get cancelled. So, you just square and add it up and you'll get the answer, and the answer will turn out to be 0, 4. Alright, on to the next one. In diagram, triangle ABC has AB is equal to AC. AB is equal to AC. BAC, as in this angle is 23. Now, AB is equal to AC, this angle is 23. So, I can see that this is an isosceles triangle. That means I know that this angle will be equal to this angle. Do I know the sum of these angles? Sum of the angles is 180 degree. If this is 23, sum of this angle will be 157. And each of this angle will be 157 by 2. Right? Okay, so I have written that. So I know that angle ACD is equal to this. Right? Okay. Now he says point D is on AC such that BC is equal to BD. This length is equal to this length. Okay. Point E is on AB such that BE is equal to ED. This length is equal to this length. I am interested in this angle, BED. Right? Mind it, I know that this angle is 157 by 2. Right? Now, in triangle DBC, this length is equal to this length. That means this angle will be equal to this angle. This is 157 by 2, this is 157 by 2. Right? Okay. Now, I need to find out this length. Okay. Now, I know that BE is equal to ED, this length is equal to this length. So, in triangle DED, this angle will be equal to this angle. Can I find out this angle somehow? This is 157 by 2, this is 23. Mind it that this angle is exterior of triangle ABD. Right? So, angle BDC is exterior angle of triangle ABD. So, 157 by 2 is equal to this plus this. So, let this be theta plus 23. Right? So, whatever this value of theta be, this angle is also theta. Right? I am interested in this angle. Now, BED is obviously it's a triangle. So, this is theta, this is theta. You have this as 180 minus 2 theta. Find out the value of theta, substitute it, and you will get the answer, which will turn out to be 60. On to the next one. Now, he says if this polynomial is exactly divisible by this polynomial, then write the value of a square c. Right? Now, the polynomial is exactly divisible by this. So, this is my dividend. So, 2x raised to power 4 plus 7. And if I divide this by this polynomial, x square plus ax plus c, I would get some quotient. And the remainder would be 0 because the polynomial is exactly divisible. Right? So, let me try writing the quotient here. Right? Here I have x square. Now, here obviously the quadratic term would be there, and I have to make sure this thing 2x raised to power 4 is made up. Obviously, x square should be multiplied by 2x square in order to get 2x raised to power 4. Right? Also, on the left hand side, I cannot see x cube term. That means the coefficient of x cube has to be 0. On left hand side, if the coefficient of x cube has to be 0, so has to be on the right hand side. Right? Now, x cube term. From where will I get it? First of all, if I multiply this x and this x square term, these two, right? Also, x cube term I will get from this linear term and this one, right? So, from here I am getting 2ax cube, but x cube I have to make it disappear. That means I need minus 2ax cube. So, that means the coefficient here should be minus 2a. Right? You can do the long division method also, you can get that, but I think we are old enough to write this directly. Right? Now, coming on to the constant term, here I can see the constant term is 7. Constant term can just be attained using this constant term and this constant term. So, I will write this constant term to be 7 by c. Alright. Now, I have written the two polynomials, left hand side and right hand side. Now, two polynomials are equal. Now, when two polynomials are equal, the corresponding coefficients will be equal. Now, obviously, I will not be comparing the coefficients of x raised power 4 because I have made sure that their coefficients are same. And obviously, I will not be comparing the coefficient of x cube because I have made sure that they are the same. So, let me write the coefficient of x square. On left hand side, the coefficient of x square is 0. On right hand side, the coefficient of x square. Let me write x square. So, x square here, so coefficient 7 by 6. X square term can also be achieved if I multiply x term and x term here, so these two, so minus 2a square. And x square term I can attain from here as well, so plus 2c. This is the coefficient of x square on right hand side and this has to be equal to 0. One condition. Now, let's compare coefficient of x square is done, so coefficient of x. So, left hand side, obviously, the coefficient of x is 0. On right hand side, let me write the coefficient of x. Obviously, I cannot multiply anything by x square in order to get x term. So, first x term I'll get from here. So, this one. So, this is 7a by 3. And the next one I'll get from here. So, minus 2ac. This is the coefficient of x on right hand side and this has to be equal to 0. Second condition. And obviously, I will not be comparing constant term because I have made sure that they are the same. Right? Now, from these two equations, I need to find the value of a square c. Now mind it, as soon as I take the LCM here, I'll get 7 minus 2a square c plus 2c square, which is equal to 0. Right? A square c quantity is here. That means all I need to do is find the value of c square. Now, from here I can see that a cannot be equal to 0. Because if a turns out to be 0, c will become an imaginary quantity. You can check that out. Right? Since a is a non-zero quantity, I can cancel it. Right? That means from here I can get 7 minus 2c square is equal to 0. Basically, I'll get the value of c square, which turns out to be 7 by 2. Substitute this value of c square here and you'll get the answer. And the answer turns out to be 0, 7. Alright, on to the next question. Write the real value of x for which this is equal to this. Right? As you can see, powers of 2 or powers of 3 are getting involved. So, let me get the like powers together. Right? So, 3 raised by x plus 2 here and minus 3 raised by x. And I'll shift all the power of 2 to that side. So, 2 raised by x plus 5 minus 2 raised by x plus 2 minus 2 raised by x. Right? Now, obviously, I can take 3 raised by x common. Right? I'll be left with 3 square over here. Because I need to write 3 raised by x plus 2 as 3 raised by x into 3 square. I hope you know the laws of exponents. So, this is 3 square minus 1, which is ultimately 8. So, I'll write it 8 is equal to, now I can take 2 raised by x common. I'll be left with 2 raised by 5, which is 32. Minus here, I'll be left with 2 raised by 2, which is 4, minus 1. Right? So, this becomes 27. Right? As you can see, 8 is here, 27 is here, 27 can be written as 3 cube and then I'll get it here. So, I'll get 3 raised by x minus 3 is equal to 2 raised by x minus 3. This obviously I can write as 3 by 2 raised by x minus 3, which is equal to 1. Right? Left hand side I have a power of 3 by 2, right hand side I need to write as a power of 3 by 2, so I'll write 3 by 2 raised by 0. Obviously, bases are same, powers will be same, and I'll get x as 3, and you will write the answer as 0, 3. On to the next question. In diagram, the rectangle is divided into 9 smaller rectangles. So, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. So, these are the smaller rectangles. The areas of 5 of these rectangles are given. So, area of this rectangle is 3, area of this rectangle is 1, area of this rectangle is 2, 5, 10. Right? Write the area of the rectangle labeled R. So that means I am interested in the area of this rectangle. Right? Now, area of this rectangle. I know that area of rectangle is length into breadth. Right? So as you can see, various areas are given and I can start by any of these. Now you will say, let's try to involve one variable, which is A, perhaps, or X, whatever you want to call it. But since I know that the answer will be a real number, instead of starting with the variable, let me just assume the length of the rectangle, right? So, if I consider this rectangle, the area is 1. So, I can consider the length and breadth to be 1 each. right? I can do that because I just need to get the answer. Now, let me come to this rectangle. Now, I know since this length is 1, this length has to be 3, right? Now, this length is 3, that means this length has to be 3. Now, the area of this rectangle is 5. If one of the length is 3, that means this length has to be 5 by 3. Right? Now, this length is 5 by 3, that means this length is 5 by 3. Now, come to this rectangle, right? The area is 10. If one of the length is 5 by 3, the second length has to be 6. Right? Okay, so that means for this rectangle, I already know one length. That means all I need to do is find out this one. This I can easily do it because this length is 1, this length is 1. That means since this area is 2, this length has to be 2. Right? For this rectangle, this length is 2, this length is 6. The area would be 2 into 6, that is 12. You can involve a variable also, that's also absolutely fine. Now, let's move on to the next one. He says, write the least natural value of n for which each of these, as in this one, is either a perfect square or a perfect cube. Right? Each of these. Now, I can say that here I have n. So, that means n either has to be a perfect square or a perfect cube. And I need to find the least natural value of n. Right? So, let me see what can n be. Can n be 4? Maybe I should start with 1 actually. But if I look carefully, n minus 9 is getting involved, right? This number has to be a natural number itself. So that means n has to be greater than 9 anyway, right? A perfect square or a perfect cube greater than 9. So that means I will start with n equal to 16. Then I will check for n equal to 25, then 27, because perfect cube also I need to check, and 36. When I check n is equal to 36, I can find that each of these quantities is either a perfect square or a perfect cube. That's why the answer is 36. Alright, on to the next one. He says in triangle PQR, PQ is 4, PR is equal to QR is equal to 14. So let me make my triangle first. So suppose this is my triangle PQR. Now this length is 4, this is 14, and this is also 14. Now he says T is a point on PQ such that Q lies between P and T. So if I extend this, my T is maybe here. And he says RT is equal to 16. So if I join RT, this length is 16. Right? Now he says write the length this. Now as you can see, QT is getting involved. In short, I need to find this length, QT. Right? This one. Now let's see how should we proceed. Now, as you can see, PQR triangle, this side is equal to this side. It's an isosceles triangle. A very important construction in isosceles triangle is dropping the perpendicular from here. Right? Because I know this perpendicular will also be the median. So that means this entire thing is 4. This will be 2. This will be 2. So let me name this point as x. Right? Now, I am interested in QT. Now, if I consider RST, I can find QT provided I know this length, RS, right? RS length I can easily find from which triangle? PSR. Why? Because this is also 90 degrees. This is 14, this is 2. This length I can write using Pythagoras theorem, and it will turn out to be root 192. Now, in triangle RST, you can apply the Pythagoras theorem. You can get the value of QT, just put it, and your answer will turn out to be 60. On to the next one. Now he says the sequence 2, 5, 10, 50, 500, 25,000 is formed so that each term after the second is the product of the two previous terms. So 10 I can say is 2 into 5, 50 I can say is 5 into 10, 500 I can say is 10 into 5, 50, and so on. He says the 13th term ends with exactly k zeros and I need to write the value of k. Right? Now my sequence is what? 2, then 5, then 10, then 50, then 500, then 2500, and so on. As you can see, third term has how many zeros? 1 0, then 1 0 here, then 2 zeros here, then how many zeros? 3 zeros here, right? Now, if I can see, if I multiply these two terms, factor of 2 is already there. That means I can get the number of zeros from here. So 2 plus 3, that is 5. Next, you will find out that the number of zeros would be 8. Now, I think the pattern is clearly visible. 1, 1, 2, 3, 5, 8. 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8. In fact, this is nothing but the Fibonacci series or sequence, right? You need to tell me what 13th term will end with exactly K0. So write the value of K. Just write it down and you will find that the 13th term ends with 89. You know the sequence, just keep writing the terms in the sequence and you'll get the answer. Alright, on to the next one. In square ABCD, CF bisects angles ACD. So that means this angle is equal to this angle. BQ is perpendicular to CF, so this 90 marked, right, etc. Now DQ is given to be 14. Then write the length of PE. So PE is here, right? So let me just try to remind myself the properties of the square, right? All the sides are equal, all the angles, they are 90 degrees. Also the diagonals bisect each other. That means AE is equal to CE and BE is equal to DE, right? Okay, so which property of square should I use? Right? Now I can see that BE is equal to DE. This length is equal to this length. That means E is the midpoint of DB. Since midpoint is getting involved, might be midpoint theorem might be getting involved, right? It might be the case. Now, if I want to apply midpoint theorem, I have a midpoint, but I don't have any parallel line, right? I don't have any parallel line. So what I can do is, since I want to find out this length, and I have to make use of the fact that E is the midpoint, that means through here, I should have my parallel line. So what I can do is, from here, I can draw a parallel line. Since I have to make use of this 90 degree, I can draw a line parallel to PQ. Right? So from here, let me have a line parallel to PQ. So maybe it is something like this. Right? Let this point be R. Right? Now, what can you say about DR and RQ? I know that DQ, entire length is 14. But what about these individual lengths? Now, mind it, I have made sure that this ER is parallel to DQ. Right? So, consider triangle DBQ. So, triangle DBQ. I can see that E is the midpoint of this side and this side is parallel to this one. That means R should bisect the third side, which is CQ. R should bisect, that means DR is equal to RQ. This I can say by converse of midpoint theorem. Right? So that means this length is equal to this length. Right? The entire is 14, this is 7, obviously this is 7. But I am interested in the length PE. Right? I do not care about RQ. But mind it, I have not utilized the fact that this angle is equal to this angle. Right? And I can see that here it is 90 degrees. And since these two lines are parallel, can I say that this angle is also 90 degrees? Right? Okay. Now, if I look carefully, can I say that triangle CQP is isosceles? Triangle CQP is isosceles. I can clearly see it. This is the angle bisector, which is the perpendicular. This side, CQ, has to be equal to CP. Right? Also, if I consider this triangle, CRE, the big one, can I see that triangle CRE is also isosceles? That means CR is equal to CE. CR is equal to CE. But I am interested in PE. I have involved CE, I have involved CP, but I want PE. So that means I can subtract the two. Subtract the two. So I can see that RQ is nothing but PE. Now I want the length of PE. I should know the length of RQ. And I know that RQ is 7. So answer is 0, 7. Alright, on to the next one. Now he says if x is a real number satisfying this, then you need to write the value of x square plus 1 by x square. Somehow I have to use this that x cube plus 1 by x cube is equal to 2 root 5. Right? And then move on to x square plus 1 by x square. Now, mind it, I must have tried to get the value of x plus 1 by x. But the cubic equation that I get, it actually is not very nice. Right? So I am unable to proceed from using the usual method. Right? That means to find out the value of x plus 1 by x. It's a bit difficult. So what else can I do? Now I can see the power 3 is getting involved and power of 2 is getting involved. Right? Somehow I need to relate the two powers, that is the power 3 and power Now clearly these two are 4 prime numbers. Directly involved नहीं हो रहा है. Now 3 भी involve करना है, 2 भी involve करना है. That means maybe I can talk about the power 6, right? Because power 6 will also accommodate power 3 and it will also accommodate power 2. So maybe let me just try to recreate the power 6. Now here the power is 3. Now since I want power 6, I will just square this up. So I'll get x raised power 6 but plus 1 by x raised power 6 plus 2 into x cube into 1 by x cube obviously gets cancelled is equal to 2 root 5 whole square which is 20. Right? In short, I get the value of x raised power 6 plus 1 by x raised power 6 as 18. Now, from here, if I want to generate power 6, I need to cube it. Right? So what I'll do is, I will just substitute this as p and then cube it up. So I'll get x raised power 6 plus 1 by x raised power 6 plus 3 into a into b. Remember, so x square into 1 by x square cancels into a plus b. So that is x square plus 1 by x square, which is equal to t cube. Mind it, this value I already know is nothing but 18. Right? And here x square plus 1 by x square has been generated, which is nothing but t. Right? In short, using this equation, I just need to find the value of t. So I can see this is a quadratic in t, cubic in t. So t cube minus 3t minus 18 equal to 0. I can see that one of the roots is 3 easily, t minus 3. You can write the second quadratic factor, but that will not give you any real solutions. So just one real solution, which is 3. That is why the answer is 0, 3. Alright, the next one. A 2-digit number has the property that the square of its 10th digit plus 10 times its unit digit and so on. Basically, I need to talk about the 10th digit and the unit digit. So I will suppose my 10th digit to be x and my unit digit to be y. This is my 2-digit number. Right? Now he says has the property that the square of its 10th digit as an x square plus 10 times its unit digit, so plus 10y equals square of its unit digit, so that means y square, plus 10 times its 10th digit, so that means 10x. Right? He says write the sum of the smallest two-digit number which have this property and are prime. Now, I think I missed out one word. He says write the sum of smallest 3 two-digit numbers. Smallest 3, right? Which have this property and are prime numbers. Now, I have this relation. Now, I can see that x is a digit, that means it will vary from 1 to 9. And y is a digit, that means it will vary from 0 to 9. So, either I can just substitute the value and guess the answer, or I can see that this polynomial in 2 variables actually can be easily factorized. Let's see. So, let me shift everything to this side. So, x square minus y square plus 10y minus 10x equal to 0. I think I can see that one factor is x minus y. Here I will be left with x plus y and here I will be left with minus 10. Right? So one condition is x equal to y or x plus y equal to 10. Now x equal to y, that means the tens place and the units place, they are the same. So that means my number can be 1, 1, 2, 2, as in 11, 22, 33, but it has to be a prime. That means I will have just one number, that is 11. Now x plus y equal to 10, so let me just start. So if x is 1, y is 19, which is a prime number. Then if x is 2, y is 8, 28, which is not a prime number. Then 3 and 7, 37, which is a prime number itself, right? So 11, 19, 37, these are the smallest two-digit numbers and I can find the sum. And the answer turns out to be 67. Alright, so the next question is, in triangle DEF, the length of altitudes through DEF are 20, 24, 30 respectively. So I have a triangle whose altitudes are known to me. So DEF, this length is 20, this length is apparently 24 and apparently this is 30. Right? Now he says write the sum of the sides of triangles rounded off to nearest integer. Right? Sum of the sides. Now first of all, as I can see, the altitudes are given to me. Now altitudes are involved in what parts? Altitudes and triangles. Obviously I need to involve area. Right? And I need to involve the sides also. So let me just name this side as x, this side as y, this side as y. Now I can write the area of triangle as half. If this is the base, so x into 20. So let me just write it 20 into x, right? I can write with this as a base. I can write the area with this as a base and this as the altitude. So half 24 into y, and then I can write half into 30 into z. Obviously, these three areas will be equal, right? So this is 10x basically. This is 12y. This is 15z. And this entire thing is obviously equal to the area, which is the capital A. That means if I want to find the sum of the sides, that means x plus y plus z. All I need to do is find the value of A. Why? Because I can get the value of x, I can get the value of y, I can get the value of z. I'm interested in area, right? Now area I've already utilized using the altitude. Is there any other way in order to involve area of the triangle? Which includes side also. Obviously, I'm talking about the hero's formula, right? Area of the triangle can be written as square root of s, which is the semi-perimeter, into s minus a, into s minus b, into s minus b. Right? Now, semi-perimeter as in x plus y plus z divided by 2, which I can get in terms of a. But if you see, I get the value of x from here, 10x equal to a, then that means a is equal to a by 10, and y is equal to a by 12, then z is equal to a by 15. The thing is, these denominators are there. I can proceed with this. I mean, it's not that big of a calculation, but still fractions are getting involved, and I get a little bit scared, right? So, mind it, area is in my hand, right? I have to suppose the area. Now, I want something so that this 10 cancels out, 12 cancels out, 15 gets cancelled out. So, I can suppose my area not as A, but as 60A. Why? Because I can get my x as how much? 6a. I can write it as x as 6a. Y can be written as 5a and z can be written as 4a. I mean, some word calculation have been reduced. So instead of area as a, I will take it to be 60a in order to reduce my calculation. Alright. And I think we should pay attention to the point where we can use the calculation because that reduces the error probability. Right? So x, y, z aa jata hai. So s is equal to this plus this plus this by 2. So that means 15a by 2. Still fraction. But it's okay. At least not that bad of a fraction. Just substitute it, right? So this is square root of 15a by 2 into 15a by 2 minus first is x. So we can write 6a. Then we can write minus 5a minus 4a. From here you'll get the value of a. Right, I will leave up that to you. And now let's come back to it. I want x plus y plus z, right? X plus y plus z, that is nothing but 15a. This plus this plus this. So substitute the value of a and you'll get the answer. And approximately it turns out to be 91. Alright, on to the next one. He says write the number of integers between this and this. Now, parentheses, outside the parentheses, I have 4. That means this number is in the base 4. This number is in the base 4. Right? Now, I want to write the number of integers between this and this. Now, if I can somehow convert it into mixed fraction and this also into mixed fraction, I can count how many integers are there in between. Right? But the issue is the base is 4. Right? Usually, when I say the number like 526, I am saying that that is in the base 10, right? That means I'll be using the digits from 0 to 9. That is why the base 10. Now the base 4 is there, that means I'll be using digits 0, 1, 2 and 3. Right? So let me write down the counting. So obviously I will start with 1, then 2, then 3. Now obviously 4 is not there, right? That means I will move on to the next number which contains only these 4 digits. So that will turn out to be 10. Which you usually call 10, but here I'll just call it 10, right? Then 1, 1, 1, 2, 1, 3, then 2, 0. Then 2, 1, 2, 2, 2, 3, then 3, 0. Then 3, 1, 3, 2, 3, 3. Then that is 1, 0, 0. And so on. You can write the counting. And it is actually very interesting. But I'm not interested in the counting. I'm interested in this number. So let me divide 1, 2, 2, 3 by 12. As in 1, 2, I should call it 1, 2, not 12. Right? So obviously 1, 2 into 1, that is 1, 2. So this is 0 and I will get 2. Obviously I need another number, but first I need to put in 0 over here. So this becomes 2, 3 and then 1, 2 into 1, 1, 2. Subtract it, you will get it 1, 1. Right? Further division is not possible. That means this number can be written as 101, 11 by 11 by 12. I'm used to the decimal system. Right? Negative sign is there, so negative sign is there. Right? Now, let me talk about this number. So that means I need to divide 3212 by 12. Right? Now I need to check 1, 2 into 1 or 1, 2 into 2. I need to check. So what I can do is I can check. So 1, 2 is here. That means 1, 2, 3, 4, 5, 6. 6 place. Right? 1, 2 into 2. That means 6 place ahead. 1, 2, 3, 4, 5, 6. I can see that 1, 2 into 2 is nothing but 30. Or 30, I should say. Right? Or I can multiply it. It's absolutely fine. 1, 2 into 2, I can multiply it if you don't like that method. So 2 into 2. That means I need to add 2 times. So add 2 to 2. So 1, 2. So this is 0. Carry 1. 2 into 1, 2 plus 1, that is 3. Interesting, right? 1, 2 into 2 is not 2, 4. It is 3, 0 actually. So that is what happens when you change the base. So 1, 2 into 2, that is 3, 0. Remainder is 2. 1 I'll get. Then 1, 2 into 1. Right? So 1, 2. Right? Now, subtract it. Either I can use the counting thing here or I can just subtract it because I will carry 1. So this becomes 1, 1. 1, 1 minus 2. 1, 1 minus 2. 1, 2. So this is 3. Then 3 and 2 comes from above. And then again 2. So 3, 0. This becomes 2. Basically, this number turns out to be 212. 2 divided by 12. Right? Now I just need to write the number of integers between the two. So minus 101 or 101. Yes, I know. Okay. So I'll start at 1, minus 101, then minus 100, then minus 33, minus 32, and so on. Basically, these numbers will be 16. Right? I'll write it. Then I'll get the number 0. Then I'll get again 1, 2, 3, and so on till 100. I can write 16. Right? मुझे 200 तक जाना है. 100 to 200 भी 16 हो गए. You can check that out. 200 तक हो गए, and then I'll get 201, 2, 3, 210, 211, 212. That means 6 more. Right? In short, I will get 56 integers between these two numbers. All right. On to the next question. Triangle ABC has a right angle at B. So this is 90 degrees. M is the midpoint of BC. Okay, so MC is equal to MB. A circle is drawn using BC as diameter. So this is the diameter of the circle, and obviously M would be the center of the circle. The tangent to the circle at P. So this is the tangent actually. Cuts AB at Q. So this is the tangent. Right? I know the angle made by the tangent at the point of contact with the radius is 90 degrees. I know this property. Right? If the angle subtended by AB at C, that means this angle is 62 degrees. I am interested in the angle subtended by MP at Q. So that means I am interested in this angle. Right? Okay. Now I know that MC is the radius and the radius would be MP as well. So if this is 62, this will be 62. Right? But I am interested in this angle. Wait a second. This is 90, this angle I want, that means indirectly I want this angle. Instead of this angle, let me get the entire big angle. Right? Now mind it, this angle is the exterior angle of which triangle? MPC. Angle PMB is exterior angle of triangle MPC. That means this big angle is equal to what? Sum of interior opposites, as in 62 plus 62, which is 124. But I want this angle, right? Mind it, can't you see that this triangle has an MPQ and this triangle MBQ? These two triangles are congruent, right? So this is 24. These two angles are equal. That means this will be 62. Right? Yeah, there are other ways also to arrive at this angle, which is 62. Right? Now come to this triangle QPM. Right? This is 90. This is 62. Obviously, you can find out that this angle is 28 degrees. So answer is 28. Right? On to the next one. Now he says at present, the sum of the ages of a husband and wife is P. Right? And this is 6 times the sum of their ages of their children, which is denoted by capital P. Right? So I know that P is equal to 6P. Now he says 2 years ago, the sum of the ages of the husband and wife. Okay, 2 years ago, right? Suppose if husband is 42, the husband would be 40. And if the wife is 44, 2 years ago, the wife would be 42, right? So if I want to write this sum, I will write the sum as P minus 2 minus 2 or minus 4, right? And this 60. Now, since I don't know how many kids are there, in fact, that I need to find out. So let me suppose that number of kids be X, right? For each of the child, I need to reduce 2 years. So that means 60 minus 2X. He says 2 years ago, the sum of the ages of husband and wife, as in this, is 10 times the sum of the ages of their children. So this is equal to 10 times this. Right? Now 6 years from now, right? So that means sum, 6 years from now. 6 years for husband, 6 years for wife. So P plus 6 plus 6, so P plus 12. This will be 3 times the sum of their children. So 60 plus. Now X children are there, 6 for each, so that means plus 6X. You need to find the value of X. Right? You have 3 equations, you have 3 variables. In fact, you can easily eliminate one of the variables and you can get the answer. The answer turns out to be 0, 3. Alright, let's move on to the next question. He says, a regular octagon covers part of another regular polygon. Now, you can see regular octagon, that means he is talking about this figure. Regular as in all the sides are equal, as well as all the angles are equal, and obviously it is 8-sided, right? And this covers part of another regular polygon. So this octagon is covering a part of another regular polygon. So this, the behind one, is actually a regular polygon. That means all the sides as well as all the angles will be equal, right? Now he says this regular polygon has n sides. Okay, so it's n-sided polygon. Okay, 7 of which are completely or partially visible. Now, as I can see, this 1, 2, 3, 4, 5. These sides are completely visible, and this one, obviously because something is hiding behind the octagon, this one and this one, they are partially visible. Right? In the diagram, the sum of the measures of the angles marked A and B. So this and this. And their sum is given to be 90 degrees. So A plus B is equal to 90. Right? Then he says write the value of n plus 7. Basically, I need to find the value of n. So, in short, I need to find how many sides this polygon has. Right? Okay. So, mind it, I have to make use of the fact that this angle is involved and this angle is involved. Now, figure out a polygon in which these two angles are getting involved. Let's see. Now this angle is getting involved, so that means this side will be getting involved, and this side, 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 this. So if I name it, so let me name this A, B, C, D, E, F, G, H, I, J. I'll write it here, J. Right? So if I can look at this polygon, A, B, C, D, so on till J, this polygon, I can see that these two angles are getting involved. Right? Now, be it any polygon, be it concave or convex, because I can see that this angle is greater than 360 degrees, is greater than 180 degrees. So that means this is a different kind of polygon. But no matter what kind of polygon it be it concave or convex, the sum of the angles remain the same. How? If it is an n-sided polygon, the sum of all the angles, as in this plus 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 this, sum of all the angles is nothing but n minus 2 into 180 degree. right? I can make use of this fact. That means this, sum of all these angles. Now this angle is getting involved. Now this angle. Now somehow I need to involve this angle also. And I need to write the measure of this angle in terms of n, right? Okay, till now what we haven't used, that the hidden, because obviously it is partially hidden, this is a regular polygon. How do we write measure of an angle in a regular polygon? This, the hidden one, partially visible one basically, this n-sided polygon will have all the angles equal, right? So that means this angle, this angle, this angle, this angle, this angle, this angle. These are basically angles of the regular polygon. How do we write the measure of the angle of the regular polygon? Now I know that if number of sides is n, the total sum of angles would be n minus 2 into 180 degree. Now since all the angles are equal, right? If I want to get the measure of a single angle, I will divide it by n. Right? So I'm hoping it is clear that the measure of this angle is nothing but n minus 2 into 180 degree divided by n. And measure of this angle is also the same. This angle is also the same. This. Right? So basically if I add this, how many these are? 6. Right? So basically if I want to find the sum of all these 6, I can write it as 6 into n minus 2 into 180 degree whole divided by n. Alright. So what I have done is, I've taken this angle, this angle, this angle. Okay. Now let's come to this angle. So B, right? Okay. B के साथ मुझे A plus B चाहिए, तो B plus A तो हो जाएगा. That is not a big deal. The problem will be created by these two angles. Do we know the measure of these two angles? I think we can. Why? Because I know this angle. This angle is nothing but the angle of a regular octagon, which I can easily write, regular octagon. Now, octagon has 8 sides, so that means sum of all the angles would be 6 into 180 degree. Whole divided by, since 8 angles are there, whole divided by 8. So this will come 3, this is 4, this is how much? 45. This angle actually turns out to be 135 degree. So this is 135 degree. That means this angle would be 225 degree, right? Because obviously sum of these two angles is 360, right? Now same 135 is this, that means this will be 225. So this plus this plus this plus this plus this plus this, already written, plus B plus 225 plus 225, so maybe I'll just multiply it by 2 plus this angle, which is A, is equal to. Now if I can write the sum of all these angles, because I can see this is also a polygon, right? Can I see that? Obviously regular name, but it's okay. Now how many sides does this polygon have? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11? मैं कहाँ से count किया था? Oh, यहाँ से count किया था. Okay, let me try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Right? Now, since 10 sides are there, I can say sum of the angles is nothing but 8 into 180 degree. Right? Now, as you can see, A plus B, you can substitute it as 90 degree. You know this value. Basically, this is an equation in n. You can find the value of n, and then you can write the value of n plus 7. The actually answer is 90. N plus 7 is 90. Alright, let's move on to the next question. Now he says, suppose m and n are real numbers such that m root n plus n root n is equal to 308 and m root n plus n root m is 340. Write the value of m plus n. Using these two equations, I need to talk about m plus n. Now if I look carefully at the terms, I can see m is there, then root m is there. Okay. N is there, then root n is there. Okay. M is there, root n is there, n, then root m. Now, if you can see, the recurring term is basically root m and root n. Because root m and m, they are directly related. One is the square of the other, right? Same goes here. So, root m and root n, they are getting involved again and again. And since radical sign is getting involved, it is a bit difficult for me to look at the equations precisely. So what I do is, since I don't like radical sign, I will just substitute root m as x. and then I will look, substitute root n as y. Alright, so I have m here, so m is nothing but x square, so x square into x, which will give me x cube, obviously, plus, now n y square into y, so this becomes y cube, which is equal to 308. Similarly, you will do that, so I'll get x square y plus xy square is equal to 341. Right? Now, using these two equations, I think you can easily find the value of x plus y. I think you can. Look, I have x cube plus y cube here. Then I have x square y plus xy square. Mind it, what I can do is I can multiply this equation by 3. So this becomes 3 into x square y plus xy square is equal to 341 into 3. I multiply the entire equation by 3. Now look at this term and this term. If I add these two, what will I get? I will get the identity x plus y whole cube. Right? And this if I add, I will get 1331. Which is nothing but 11 cube. That means you know the value of x plus y, which is 11. Right? Now, let me see. I need to find the value of m plus n. Right? So, let me just replace it. So, basically, I want x square plus y square. Right? With regard to that, I already know x plus y. That means all I need to do is find the value of x, y. How do I do that? Find the value of x, y. Wait a second. What I can do is I can take x, y common from here. Right? And I will be left with x plus y, which is equal to 341. Now, this is nothing but 11. So, x, y also I can get, which turns out to be 31. You know x plus y, you know x, y, you can easily find the value of m plus n. First of all, obviously, you'll find the value of x square plus y square. And the answer will turn out to be 59. Alright, on to the next one. The base of a triangle is 4. The median to the base is root 6 minus 2. And one of the base angles measures 15 degrees. So, let me make a rough diagram. So, suppose my triangle is something like this. This angle is 15 degrees. Base of the triangle is suppose 4. Yeah, I know, very good. Okay. And the median to the base. So, median, this would be this one. This length is root 6 minus root 2. Let me name the triangle, obviously. So, A, B, C. Let this point be D. Now, since AD is the median, I know that this length is 2 and DC is also 2. Right? He says, write the acute angle between the median and the base. Median is here, base is here. Acute angle. So, that means I can say this is the one. Right? I am interested in angle ADB. Angle ADB. Right? Now, obviously, somehow I need to use this angle, which is 15 degrees. Now, 15 degree is kind of a standard angle, right? I mean, I know sine 15. I mean, if you don't know the values, you know the formula of sine of A minus B. You know cos 15, you know tan 15. This is 15 is a standard angle. That means I can use trigonometry. But for trigonometry, I need a right triangle. Can I say a right triangle? Absolutely not. You cannot. So that means I need to drop a perpendicular. Right? And it is very obvious that I will drop the perpendicular from A onto the base. Right? And let this point be E. Right? Now the problem is, if I want to utilize 15 degrees, I don't know AE, I don't know EC. I know some part of EC, that is EC. Right? I don't know this and I don't know this. That's absolutely fine. What I can do is, I can suppose this length to be H and let this length be X. Right? Now, let me try to find the value of H and X. Why? Because I can find this angle provided I know this length and this length by means of trigonometry. Right? Or by means of common sense also, for that matter. You realize why. Now, let me write the relationship between H and X. Right? Obviously, 15 degree use karna, so I will go in triangle AEC, as in AEC actually, the big one. Right? This H use karna and X use karna, so this by this, perpendicular upon base. So H by base is the entire thing, this is X, this is 2, I mean the entire is 2, so x plus 2 is tan 15 degrees, which is nothing but root 3 minus 1 divided by root 3 plus 1. Cool? Right? Another relation I need. Also, I have to make use of the fact that this is root 6 minus root 2. So, I will go to this triangle, triangle AED. Right? H is here, X is here, this length is given, so I can apply. So, that gives 0. So, in triangle AED, I can write x square plus y, x square plus x square is equal to root 6 minus root 2 whole square. Right? Using these two equations, you can easily find the value of x. You can easily find the value of x. And you can easily find out this angle since you know h and x. So, using this triangle, you can find out this angle. This angle turns out to be 45 degrees. Surprise, surprise. Obviously, if you know more trigonometry, you can also guess the answer. But let's see whether you actually know more trigonometry or not. Alright, let's move on to the next question. Now this next question is precisely the kind of thing that you should do in test papers. That means just read the question carefully and answer it. That's it. Alright, so let's just see. He says for each positive integer n, an even sequence from this set is defined to be a sequence that satisfies the following conditions. What are the conditions? Each of the terms is an element of the set. Right, so obviously I will be using numbers from the set itself. Then the sequence has to be increasing, right? So that means the sequence might be 1, 4, 5. But do you think the sequence can be 2, 3 and 1? No. This case the sequence is not increasing. Right, okay, so we understand the meaning. Then also he says that terms in odd number position are odd and terms in even number position are even. Right? So any sequence, if I take any sequence, I can see that this is the first place, this is the second place, this is the third place, this is the fourth place. So first place, it's an odd number, right? So that means odd numbers would be there. So I can put in 3, right? I cannot put in 2 here, right? This is a position second, that means even position is there. So that means maybe I can put 4, right? Then third, again odd, so maybe an odd number, so maybe 7, and so on. Right? Now he is saying an even sequence from this R. Now he says, now first one is 1, right? Just 1. Now since 1 just have one position, odd number is there. Since 1 is there, so automatically, trivially it is increasing sequence, and obviously element is from the set itself. All the 3 conditions are satisfied. Second is 3, same goes. Third is 1, 2. Now first odd, second even. Increasing, yes. Then 1, 2, 3. Odd, even, odd. Increasing, yes. Right? Now he says, your job is to find the number of even sequences from this set. Right? Okay. So I have this set. That means I'll be using the numbers 1, 2, 3, 4, 5, 6, 7. Right? Now as you can see, number of even sequences. So I can make cases on the basis of the length of sequences. Whether 1 element is there, whether 2 element is there, whether 3 element is there, 4, 5, 6, 7. Right? And obviously the sequence will not be longer than 7 elements. Right? So let me just try to do that. So first case is 1 element sequence. Right? Obviously 1 element, so 1 place, and this is first place itself. So that means only odd number will come. So I can have 1. Then 2 I cannot have, I can have 3, then 5, then 7. Done, exhausted. 1 element sequence is done. 2 element sequences. Right? Now 2 elements are there, that means first odd, so odd number should be there. Second, even number should be there. Also the sequence has to be increasing, so I have to be careful. Right? First odd is there, so let me start with 1. Now second even, so I can have 2. Then maybe instead of 2, I cannot have 3, maybe I can have 4, so 1, 4 is there. I cannot have 1, 5, I can have 1, 6 though. Done. Sequence is starting with 1 exhausted. Now, odd lena, so I will start with, I cannot start with 2 because I need an odd number, 3. Right? Now, I can't write 3, 2 because the sequence will be decreasing then. So, 3, 4 would be there. 3, 5, no. 3, 6, yes. 3, 7, absolutely not. Right? Then obviously I cannot have a sequence starting with 4. I have to start with 5. So 5, 2 I cannot write, 4 I cannot write, so 5, 6. Done. Now I cannot have a sequence starting with 7 because I don't have a number to write in the next place. Right? So these are the 2 elements. One. So how many these are? These are 6 in number. And these were 4 in number. Right? Similarly, you can write 3 elements sequences. Right? So 1, 2, 3, that means odd, even, odd. So I will start with 1. Right? Then I can have 2, then I can have 3. Right? So 1, 2, 4 I cannot have 5. Then 1, 2, 6 I cannot 7. Done? So 1, 2 exhausted. So 1, 4 I can go. So 1, 4, 5. 1, 4, 7. Just write it down. You know how to write it, right? 1, 4 exhausted. So I can have 1, 6, then 7. Now, sequences starting with 1 exhausted. So let me write with the 2 starting of the case is 3. 3, 4, 5. Then 3, 4, 7. Done? 3, 4 exhausted. I can have 3, 6, and then that will be 7. Done? Sequence exhausted with the 3 as the first one. Done. So I will go to 5. So 5, 6, 7. That's it. I cannot start the sequence with 7. Because it's very obvious. That's it. 3 element sequences would be 3, 3, 3, 10. Similarly, you will write the 4 elements, 5 elements, 6 elements, 7 elements. Provided you have good concentration, you will have the correct answer, which comes out to be 33. Alright, so the next one. He says in triangle MNO, angle MNO is 90 degrees. So let me make that first. Right, MNO. So this angle is 90 degrees. The perpendicular bisector of MO, perpendicular bisector. Maybe it is something like this. This is equal to this and this is 90 degrees. Intersect segments MN and MO at points Q and P respectively. Right? If area of PQNO, so area of this, ratio area of the bigger triangle, that is 3:5. And ON is 11, so this is 11. I need to find the value of root 15 mm. So basically I need to find the value of mm. That means this length. Right? Okay. Now I have to make use of this fact that this ratio of this area and the area of the entire triangle is 3:5. Right? I have to use that. How should we proceed? Now he says if 3:5, so if the area of PQNO is 3x because ratio used here, right? So if this is 3x, the entire thing would be 5x. So area of triangle MNO is 5x. Right? So this is 3x area and this is the entire is 5x, that means this is 2x. Done? Okay. Now what else can I use? Now I have to make use of the fact that MP is equal to PO. Right? This is equal to this. Now that means somehow some median would be involved. Right? That means QP has to be the median of some triangle. Do you think QP is the median of some triangle right now? Absolutely not. So that means I have to generate that triangle. So since I want QP as the median, I will join Q and O. Right? Okay. Now, as you can see, MQO, QP is the median. Now I know in a triangle, the median divides the triangle into 2 equal areas. Since this length is equal to this length and height is the same, these 2 areas are equal. That means these 2, area of MQP and area of PQO, these will be equal. If this is 2x, this has to be 2x. Right? Now remember, the entire area was 3x, out of which this is 2x, that means area of QNO is x. Done? Now, my problem is I need to find the value of MN, this entire thing. How can I utilize that? Now, and also I have to use this fact that this is 11 in length, right? So that means if I want to use this length and this triangle is getting involved, and this is 90 degrees, somehow I'll be involving the area of this triangle, right? Also, with this as the length or the base, I can say this is 90 degrees. Maybe I can have this as the altitude. So that means I can use the area of the entire thing also, MNO. Now, wait a second, MNO. This is x, this is 5x. common base that they have. And this is the altitude of the smaller triangle and this is the altitude of the bigger triangle. Can I see that the ratio of the altitude, since base is the same, ratio of the altitudes will be 1:5, ratio of their area. Hoping that's okay. So can I say that Qn divided by Mn is nothing but 1/5. Right? So if this length is suppose y, the entire length is what? Pi y. That means this length is 4y. Now you'll be like, what's the benefit in that, right? Now, as you can see, I need to find the length Mn, and I have been involving this length. In fact, all I need to do is find the value of y. If I can find out y, I can find the length Mn. That means I need an equation in y. Now let's see, equation in y. Also, I have to use this. So this is 11. This is, maybe I can use it. This is y. Do I know this length QO in terms of y? In terms of y. Can I see that MQP and QCC? Can I see that these two triangles are actually congruent only? I have not said it in corresponding manner, but you can write it, right? So can I say that if this is 4y, this also will be 4y? This is 4y, this length. This is y, and this is 11. Can you find out the value of y? Yes, you can. If you can find out the value of y, you can find out the value of 5y, which is the length Mn, right? And you just need to multiply by root 15, and your answer would be there, and the answer turns out to be 55. Alright, on to the next question. He says, write the number of ordered triplets a, b, c of positive integers for which the LCM of a, b is 1000, LCM of b, c is 2000, LCM of c, a is 2000. Now since LCM are getting involved, I think we should just write the prime factorization first. So this would become 2 cube into 5 cube, right? LCM of a, b. And LCM of b, c is nothing but 2 raised to 4 into 5 cube. Then LCM of c, a is nothing but 2 raised to 4 into 5 cube. Since LCMs are getting involved, it's better to write the prime factorization. Now he says, how many ordered triplets are there? Right? Which satisfy all these three conditions. Now ordered triplets. Right? So maybe I can find out in how many different A's. In how many different ways can I have my A? Corresponding to that, how many different ways can I have B? And corresponding to that, in how many different ways can I have C? And probably if I know all of that, I can find the number of ordered triplets. Let's see. Now, I have to make use of the fact that LCM of a, b is 2 cube into 5 cube. Right? Now, mind it, LCM is given to be 2 cube into 5 cube. You can see there are just powers of 2 getting involved and just powers of 5 getting involved. So, maybe I can find out in how many different ways can I have powers of 2 involved first. Right? Because I know A would have some power of 2 and some power of 5. Similarly, B would have some power of 2 and some power of 5. And C would have some power of 2 and some power of 5. So let me see in how many different ways can I have powers of 2. Let's see. Let's study that. Right? Now, since LCM is written like this, so I will write A, B, C. Right? I'll start. Now, I know 2 cube is to get involved. So in both of these, at least one of them has to have the power 2 cube, right? Power 3 basically. So let me start with A, which has the power 3. So I'm just talking about powers of 2 here. Right? Powers of 3. Now corresponding to that, maybe B have the power 0. That is the case, right? Because then also the LCM would be 2 cube only, right? Because maximum power I take in the LCM, right? Then maybe I can have power 3 over here and power 1 here. And power 3, power 2, power 3, power 3. Can I have power 3 and power 4 over here? Absolutely not, because we will be changing the LCM then. Right? Obviously, that is not the case. Right? Now, I have talked about A, B. What else? Also, I can interchange it. So, maybe I can have power 2 here and power 3 here. Power 1 here, power 3 here. Power 0 here, power 3 here. Done? Now, let me move to the second condition. He says B, C, the LCM has to be. 2 raised to power 4. But that means it needs to have the power 2 raised to power 4. 2 raised to power 4. Now B, if it has power 0, C needs to have power what? 4. Because I need the LCM to have 2 raised to power 4. Now, if B has power 1, C has to have the power 4. Similarly, 2, 4, it needs to have 3, it needs to have 4. 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 Done? Right? Now, as you can see, now let me check. LCM C, A 2 raised to 4. Let me see. The LCM is 4, 2 raised to 4 is there, 2 raised to 4, 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 2 raised to 4. Yes. That means if I write these cases of powers of 2, all of the 3 conditions are being satisfied. So, how will we see? So, either A will have 2 cube, B will have, corresponding to that, B will have 2 raised to 4, C will have 2 raised to 4. This is one such case. Another case might be A has 2 cube, B has 2 raised to 1, C has 2 raised to 4. Another such case. Then another such case. Then another such case, another such case, another such case, another such case. That means power of 2, either it will be this or this or this or this or this. Apart from these 7 cases, power of 2 cannot occur in any other way. Right? So, power of 2, it can occur in 7 different ways. Now, mind that we have just talked about powers of 2. We need to talk about powers of 5 also. So let me just quickly discuss it because I think you have the hang of it. You can do it yourself, but let me just quickly discuss it. So power of 5, let's do that quickly. Right, so 5 cube is there. So again, 3, 3, 3, 3. I know the cases, 0, 1, 2, 3. Done. And I can write 2, 3. Then I can write 1, 3. Then I can write 0, 3. Now, this one. 5 cube is there. 5 cube is there. Let's see, 5 cube is there. So I can have 3, 3, 3. Right? 3, 3, 3. Here, okay. From here, I can change my position also. Maybe I can have 0. Maybe I can have 1. Maybe I can have 2 here. Maybe I can have 3 here. Right? Now, do you think I have exhausted all the cases? Let's see. I think we are missing out one case, or maybe few cases for that matter. Let's see. Because the thing is, we had 3 over here, then we had 3 over here. And some powers of 3 over here. What cases are we missing? Let's just figure it out. 3, 3, 3. Maybe I can have more of 3 over here because then I can vary this as well. Right? So what I can do is I can have 3 over here. Right? 3 over here, 3 over here. Right? 3, 3. And instead of 0, maybe I can have 1. Because I missed that out, missed that case. Right? 3 over here, and 2. Then 3 over here, 3 over here, 3 over here. Right. Done? Because I was missing 3, 3, 0, 3, 3, 1, 3, 3, 2, 3, 3, 3. Let's see. Any other case that I am missing? Because I made sure powers of 5 are 3 here, 3 here, 3 here. 3, powers of 3, and powers of 3. Exhausted. If you can think of some other way, which I doubt you will, but if you will, let me know. So basically, what I'll do is power of 3, power of 5 basically. Either it will be 5 cube here, corresponding to that it will be 5 raised to 0, corresponding to that it will be 5 cube. One case, another case, and so on. How many these are? These are 10 in number. Right? Now, powers of 5 can occur in 10 different ways. Now, powers of 2, powers of 5, they are corresponding to each other. So that means in total I can have 70 ordered triplets. Alright, on to the next question. He says 2 circles whose radii are in the ratio 1:3. Now ratio of radii is 1:3. That means if the radiuses are, here the radiuses 3 are. Right? They are tangents to each other externally. At this point, the length of their common external tangent, either this and this, I know that these two lengths will be same. So let me just write it here that PL is equal to 6 root 3. Now he says if sum of external arcs PQR and LMN, sum of external arcs, so that means this arc, length of this and length of this. This length is given to be K and I need to find the value of K by pi. In short, I need the what? I need the value of K, right? And K is getting involved in length of arcs. Now, in order to find the length of the arc, I should know the radius and also I should know the angle subtended by the arc at the center. Now, first of all, let me just find out the radius, right? For radius, it is given that the common tangent is 6 root 3 in length. So, let me just make another separate diagram, right? This length is 6 root 3. I know this is R, this is 3R. What I can do is, I know if I join the two centers, it will pass through the point of contact, right? I know that this angle is 90. I know that this angle is 90. This is R, this is 3R. Now what I can do is, since I want to find R, I need to set up an equation in R. And since 90 degrees are getting involved, maybe Pythagoras theorem might be involved. So what I can do is, through this point, I will draw a line parallel to this. I can see that this figure is nothing but a rectangle. So this is 6 root 3. Now this was R, so this will be R. Entire is 3R. This is R, so this is 2R. Yes, a bit discrepancy is there, but it's okay. Right? This is 90, so this is 90. Also, this length is R plus 3R as in 4R. So in this triangle, you can apply the Pythagoras theorem because I can say 6 root 3 whole square plus 2R whole square will be equal to 4R whole square. You can find the value of R. R turns out to be 3. Right? So R is 3. 3R will be 9. I know the radii now of the two circles. Now, since I want to know the length of the arc, I should know the angle subtended by the arc. First of all, let me talk about this angle. Right? I'm interested in this angle. What should I do? Now, I know that the line joining the two centers will pass through the point of contact. Right? I know that this angle will be 90. I know that this angle will be 90. How should I use this? I'm interested in this angle. What I can do is, I can extend this. Right? And obviously, I can extend it. And these two will meet somewhere. Maybe here. And let that point be C. Right? Now, what do I know? I know that this is 3. Radius. I know that this is 9. Radius. And since I want this angle, first of all, I can see that this angle will be equal to this angle. Why? Just join it, you can see that these two triangles are congruent. Right? So instead of finding out the whole angle, I will try to find out half of it. And let me name it theta. Right? Now mind it, here it is 90, so here is also it is 90. So maybe in this triangle PAC, maybe I can apply trigonometry because 90 degrees is there. Right? And I need to find out this angle. I already know this length, this is 3. Somehow, if I can find out this length, PA, maybe I can find theta. Why? Because AP and CA, they are nothing. This ratio is nothing but cos of theta. Right? So this I know is 3. That means all I need to do is find the value of CA. How do I find CA? CA. This length. Now I know this length also. Why? Because this is 3, this is 9, this length is 12. I know that this is 9, I know that is 3. Can you see a pair of similar triangles? I think you can clearly see triangle PAC is similar to triangle LBA. Right? That means PA by LB, as in this by this, will be equal to this by this. CA by CB. CA by CB. Let CA be X. So CB will be X plus 12. And I know this ratio. This is nothing but 1:3. Right? 3 by 9, which is 1:3. You can find the value of X, which turns out to be 6. That means CA length is 6. Right? That means cos of theta is 3 by 6. That is 1 by 2. Cos of some angle is 1 by 2. That means that angle is 60 degrees. Right? Now this angle is 60 degrees. angle will also be 60 degrees. That means entire angle will be 120 degrees. So length of the arc is 120 by 360 into 2 pi radius, which is 3. Right, this arc. Now I need to find out this arc length also. So that means angle subtended by this arc length at the center. That means this angle. Now mind it, this is 60, obviously because these two lines are parallel. This is 60, this is 60, that means this is 60, this is 120 degrees. So that means this is 240 degrees. So plus 240 by 360 into 2 pi, radius is 9, which is equal to k. You can find out the value of k, which turns out to be 14 pi. See, so k by pi turns out to be 14, which is the answer. Now, next one. If n is the number of positive integers less than or equal to 300, that means I need to consider integers like 1, 2, 3, so on till 300. Right? That are multiples of 3 or 5, multiples of 3 or 5, but are not multiples of 10 or 15. Then write the value of n by 2. So basically, I need to find the value of n. Right? Now, n is the positive integers less than or equal to 300 that are multiples of 3 or 5. So first of all, let me just write the multiples of 3. Right? So that will be 3, 6, 9, so on till 300. Right? And multiples of 5 would be 5, 10, so on till 300. Right? Now, multiples of either 3 or 5. First of all, how many multiples of 3 are there? 10, 100. Right, by 3 into 1 till 3 into 100. Marker is there, so you can directly write it. Then multiples of 5, 5 into 1, 5 into 60. So that means 60 multiples are there. Now mind it, he says that are not multiples of 10 or 15. Now first of all, let me talk about 15. Multiples of 15 again. So it will be obviously 15, it will be 30, and so on, it will be 300. Right? I don't want multiples of 15 here. Mind it, 15 would occur here as well and here as well. But I don't want 15, right? And you have counted 15 twice. You have counted 30 twice. You have counted 45 twice. And I don't want even a single one. So that means how many, first of all, how many multiples of 15 are there? That is 20. And you have counted these multiples twice and I don't want any of them. So I will subtract it twice. Use a little bit of common sense. Right? Done. So I have separated out this number. Now, I don't even want the multiples of 10 over here. Right? Multiples of 10. So that means 10, 20, 30, so on till 300. Right? I don't want these numbers as well. So how many these are? These are 30 in number. So minus 30. But wait a second. Already 30 nahi tha. Yeah, you don't have 30 now. Right? You don't have 60. I have 60 now. Right? And 10 plus mein aana nahi tha. So basically 30, 60, so on till 300. These you actually subtracted once again. They were not even there because you subtracted it when you were subtracting the multiples of 15. They were not even there and you subtracted it. So you need to add these numbers. So that means this is how many multiples are there? 10. By pure logic, you can directly write the answer because that will be 100 plus 60 minus 40 minus 30 plus 10. That will give you n, and n turns out to be 100. N by 2 turns out to be 50. You can use set theory also, but you need set theory when logic is there. Basically, with a simplified version of set theory. Alright, now the next question. He says in triangle ABC, the bisector of angle A intersects BC at D. So let me have my triangle first. Now AB is 52, 56, 60. Okay, so A, B, C. This length is 52, 56 and 60. Now bisector of angle A intersects BC at D. So my bisector is somewhat like this. This angle is equal to this angle, this point is D. A perpendicular to AD from B. To AD from B, perpendicular. Maybe it looks something like this. Somewhat. We don't care. Intersects AD at E. right? A line segment through E and parallel to AC, right? So it will be something like this. Intersects BC at G and AB at H, right? AB is 52, BC is 56, AC is 60. You need to find the value of DG. That means this length. Right? Now, first of all, what do I know? That AD is the angle bisector? Now, if AD is the angle bisector, do I know any theorem regarding angle bisector? Yeah, we know the angle bisector theorem, right? Now, since AD is the angle bisector, that means it divides the opposite side as in BD by DC in the ratio of the sides containing it. So, AB by AC. AB by AC. Right? Which is 52 by 60. And it turns out to be, you can easily find out, you can put this as X 56. You can write the value of BD basically, which turns out to be 26. And this turns out to be 30. Alright. Now, I am interested in the length DG. I already know what length is BD. Right? I know this length is 26. Somehow, if I can get to know this length DG, I can find BG minus BD. That will give me DG. So, I am interested in BG now. Okay. What I have not used the fact that this line is parallel to this one. Right? And that this angle is 90 degrees. Parallelism of line. Now, if this line is parallel to this one, and these two angles are equal, can you tell me what this angle is? These two lines are parallel. This is the transversal, right? This angle will be equal to this angle. Okay, wait a second. Now, you can come to triangle AHE. What sort of triangle is this? Triangle AHE is isosceles. That means this length is equal to this length. Okay. Now, mind it, this is 90 degrees. Now, on the side, now, if I have a right triangle, this is 90 degrees, and if I take the midpoint of the hypotenuse, I know that the midpoint of the hypotenuse is equidistant from all the three vertices. Why? Because this midpoint is nothing but the circumcenter of this triangle. Oh, wait a second. This is a point which is equidistant from these two vertices. Obviously, this point will be equidistant from the third one also. That means this is equal to this. Right? So, that means this is equal to this. And this line is parallel to this one. What do I infer from that? In triangle ABC, this HG is parallel to AC. This is the midpoint. That means G has to be the midpoint of DC. By which theorem? Has to be midpoint by obviously midpoint theorem. Actually, converse of midpoint theorem. Right? So that means G is the midpoint. That means BG will be equal to GC. Entire length is 56. BG will be 28. This is 28. This is 26. Obviously, this length is 2. So your answer is 0, 2. Alright, on to the next one. Let A be the set of all integers n for which this is a perfect square. Then write the sum of all elements of A. Basically, I need to find all possible values of n such that this becomes a perfect square. Right? Now, minus n square plus 19n minus 74 has to be a perfect square. That means this quantity has to be of the form k square maybe. Right? Now, how do I deal with that? Now, if this quantity is k square, what I can do is, I can shift everything to that side. I'll get n square minus 19n plus 74 plus k square. This is equal to 10. Right? Now, mind it, I need to find integral n. Integral n. Now, can I find the value of n from here? Yes, ma'am. It is a polynomial n. I can find the value of n by what? By using quadratic formula. Right? I can write 19 plus minus 19 square minus 4 into 74 plus k square. Why? Because this entire thing is c. Careful. Whole divided by 2. Right? Now, since n is an Now this is an integer. This quantity has to be an integer. Then now you want the square root thing to be an integer. That means quantity inside the square root should be a perfect square itself. So 19 square minus 4 into 74 plus k square has to be a perfect square. Right? So let me see. 19 square, that is 361 minus this is 296 minus 4k square. This quantity has to be a perfect square. Right? Now, a perfect square, that means, okay, in order to, because I want to imagine it, so maybe it will be of the form n square. Right? Now, if I shift this to that side, I'll basically get n square plus 4k square is equal to 65. Now, 4k square is nothing but 2k whole square. Now, you are saying sum of those squares is equal to 65. Very less cases are there. One will be 64, the other one will be 1. Then one will be 36, I guess. The other one will be 49. No, one will be 16, the other would be 49. Right? I don't think you'll have more cases. So you have different values of k. Corresponding to that, you can find the value of n and you'll get the answer. Add whatever elements would be there. The answer will turn out to be 38. Mind it, you can do easily, you can have the method of hit and trial in this question. You can just put in the corresponding value of n, because n is an integer. Start putting it. You know, after a certain point of time, you'll stop getting the perfect square. So if you have time and you're unable to think of this method, you can use hit and trial also. Alright, on to the next one. He says the altitude drawn to hypotenuse of a right triangle divides into two parts, 9 cm and 16 cm. Now, I have a right triangle, somewhat like this. The altitude drawn to the hypotenuse. Obviously, this angle is 90 degrees. A, B, C. Altitude drawn to the hypotenuse. This is the hypotenuse. Let this point be D. Divided into two parts, 9 and 16. BD is 9, DC is 16. Right? Now he says from the vertex of the larger acute angle of the triangle. So acute angle, obviously these two will be acute and this would be the larger of them for very obvious reasons. Right? From this vertex, a straight line is drawn passing through the midpoint of the altitude. So this is the altitude, midpoint, let this be E, and AE is equal to ED. A line is passing through these 2 points. Right? Okay. Now he says, write the length rounded off to the nearest integer of this segment, which segment? This one, enclosed inside the given triangle. So that means enclosed inside the given triangle. So I am interested in the length BF. Right? Okay. Now, first of all, I need to find out this length. Now, whatever I can assess, I should write it down. Now, I know that this is 9, this is 16. With the help of these two lengths, I can easily find out AD. We have done this question quite a lot of time in class 10. So, basically, I can say that AD square comes out to be equal to BD into DC. This you can write it how? Because these two triangles, ABD and triangle ACD. I am not saying correspondingly, you check it out. These two triangles are similar to one another and that is why this relationship comes up. Right? You have done that many times, so I'm not going to reiterate that. So basically, I will get AD square as 9 into 16. I will get the length AD as 12. Right? Now, if this is 12, this is 6 and this is 6. Mind it, I need BF. I already know BD. Right? This is 90, this is 6, this is 9. So this is root of 9 square plus 6 square, which is 170. Yes, 107. Cool. All I need to do is find out the value of EF. Now my aim is to find the value of EF. Now, I have to use the fact that this is the midpoint. Now, midpoint is there. Midpoint is there. So, might be midpoint theorem come into the picture. It might happen, right? Midpoint theorem. But I don't have a parallel line. I don't have a parallel line. I need to make use the fact that this is a midpoint. Right? This is a line passing through the midpoint. So what I can do is, through D, I can have a line parallel to EF. Construction. So construction is draw DG parallel to EF. Why? Because I have involved my length EF. EF and DG, they are kind of related to one another. Now, I am interested in the length EF, so let this be X. Now, I know that if this is X, this will be 2X. In order to find the value of X, I need some relation. Now, since I know that this line is parallel to this one, what else can I use? I know that this is 16, this is 9. This line is parallel to this one. I think we can see another set of similar triangles, can't we? Look at this, GDC, then FBC. Can you see that these two triangles are similar? Triangle GDC is similar to triangle FBC. Obviously, parallel lines, common, equal, by double similarity rule. Cool. Right? So that means DG by BF, which is 2x by this thing, 2x by this thing is nothing but x plus root 170. This by this is equal to DC by DC. So 16 by 25. From here you can find the value of x. Right? You need BF, so you want x plus root 170, or maybe you can directly find out the value of this, your wish, and round it off. Basically, this length turns out to be 75 root 13 by 17, I think, approximately. I don't remember it. The answer turns out to be, rounded off, 28. The answer turns out to be 16. On to the next one. He says write the maximum possible value of L, for which 2021, this is going on, by the way, can be written as sum of L consecutive positive integers. So I need to write 2021 as sum of L consecutive positive integers. Consecutive, right? Consecutive positive integers. So if I take the first integer to be n, the next would be n plus 1, next would be n plus 2, and so on, right? So sum of this. Now how many these are? These are L consecutive ones, right? So the last number would be actually n plus L minus 1. I hope you can see that, right? And I need the maximum possible value of n, right? So first of all, let me just add these up. This is nothing but an AP, right? Because obviously the common difference is 1, right? So I can take, how many terms are there? N. So L by 2 into 2n plus L minus 1 into common difference, which is 1. This should turn out to be equal to 2021. Right? So I'll cross multiply. I'll basically get L into 2n plus L minus 1 equal to 2021 into 2. Now I want the maximum possible value of n, right? This will be a natural number. Obviously, this will be a natural number, right? Because n is a positive integer, right? This is a positive integer, which is a natural number. This is a positive number, natural number. This is a natural number. This is a natural number. So I need to write this as product of two natural numbers, and I need to find the maximum value of this. Now, natural numbers, right? So first of all, let me just write the prime factorization. Now, 2021 is nothing but 43 into 47. So I'll write it. 2 into 43 into 47. Right? I need the maximum value of L. Now, do you think I should check whether L is equal to 2? L is equal to 43 to start with. Right? L is equal to 43. That means 2n plus L minus 1 will be equal to 2 into 47, which is 94. Right? L is 43. So this becomes 2n is plus 42 equal to 94. So I will get a value of n actually, a natural value, right? So that might be the answer, but I want a maximum possible. So can I take L as 47? Let me say, right? Now if L is 47, 2n plus L plus minus 1 will be 2 into 43. 2 into 43, which is 86. Now this is 47. So this is 46. The 86 minus 46, even number. That means you'll get a natural value of n. If L is 47, you are getting something n. So then that means L equal to 47 possible. So ये larger, right? Now let me see whether there will be a larger L or not, right? Another divisor. So maybe I can take combination of 2 now. So I will take 2 into 43, which is 86. Cool, right? Now if L is this, that means 2n plus L minus 1 is equal to 47. Right? Now if this is 86, n will be a negative number. Can we have n as a negative number? Absolutely not. Now if I take L as 2 into 47, again you will get n as a negative number. If you take L as 2 into 43 into 47, again you will get n as a negative number. That means L is equal to 47 is the maximum possible value. That is why 43 is the answer. Alright, the next one. Triangle ABC is right angle at B, as you can see, and has side lengths which are integers. Side lengths, as in AB is an integer, BC is an integer, AC is an integer. Right? Pythagorean triplets come into mind. A second triangle PQR is located as shown inside triangle ABC, such that its sides are parallel to the sides of triangle ABC. So PQ is parallel to AB, QR is parallel to BC, PR is parallel to AC. And distance between the parallel lines is 2. So this distance is 2, 2, 2. Right? Now he says write the sum of smallest side length of all possible triangles ABC. Right? So there will be multiple triangle lengths possible. I need to write sum of all the smallest side lengths. Okay, such that area of triangle ABC is 9 times the area of triangle PQR. Now, area of PQR and area of triangle ABC is getting involved, right? Now, these two triangles are clearly similar, right? Now, if area of triangle ABC over area of triangle PQR is given to be 9:1. Ratio of the areas of similar triangles, that is square of the ratio of the corresponding sides, right? So that means corresponding ratio of the corresponding sides will actually turn out to be 3:1, right? So that means suppose this length is x, this length will be x/3, right? Now you'll be like, ma'am, consider this length to be 3x and consider this length to be x. Mind it, I have to use the fact that this side lengths are integer. Side of this triangle, ABC. Right? So I don't want 3x involved here. I would want x to be involved here. So that I can clearly see that x is an integer. That means y is an integer. That means z is an integer. Right? That's why I'm not involving 3x, 3y, 3z. Alright? Now, if this length is x, this length is 3x. This length is no, not 3x, x/3, okay, x/3. This length is y/3 and this length is z/3. Right? I might use this. Now, what else? Since I want the smallest possible side length, basically I want these lengths. I want the triangles. I want the value of x and y. Right? What else do I know? Now, of course, somehow I need to use that this length is 2. Distance between the parallel sides. Distance between the parallel sides is given to me. And 90 degree is given. Now, first of all, distance between parallel sides. How do I use it? Parallel sides. I need to use this distance, this distance, this distance. Distance between the parallel sides is actually used in trapezium. In area of trapezium, actually. So, if I talk about this trapezium, QBCR. Area of triangle QBCR. It's half into sum of parallel sides. Mind it, I know this also in terms of x, but I know that. So x/3 plus x into distance between the parallel sides, which is 2. Right? I might be able to use this. Now, since I have to use this as well, so I can talk about the trapezium PQBA. I can write it. It will turn out to be half into y/3 plus y into 2. then I can write the area of this trapezium APRC, which is half into Z by 3 plus Z into 3. Now I have written the area of the trapezium. Mind it, area of trapezium. I know the area of this, I know the area of this, I know the area of this. And if I add the area of this, I'll get the area of the entire triangle. I can use this. So that means area of all these, sum of areas of all these areas will give me the area of the entire triangle. So maybe I can use this. So let me rewrite this because I need the space. So I'll write this plus this plus this first. So half into x plus x by 3 into 2 plus half into y plus y. I know I wrote x by 3 plus x, but one of the same thing, who cares? Into 2 plus half into z plus z by 3. Right? Area of the three trapezium plus area of triangle PQR, that is half y by 3 into x by 3. Y by 3 into x by 3. I'm adding all of these areas and I'll get the area of the entire triangle. So half into y into x. Right? Since I want xy, I need to form an equation in xy, right? So I've tried to do that. Since area, the distance between the parallel lines are given, maybe I can use area of trapezium. Right? Okay. First of all, obviously this. Half common, but half. Cancel that out. Right? I will get 4x by 3 plus 4y by 3 plus 4z by 3. Okay, where is my 2? 2 disappeared now. So basically, this will become 8x by 3, 8y by 3 and 8z by 3 plus xy by 9 equal to x by. I don't like fractions, so you know that, I know that. So into 3, into 9, I can multiply everything by 9, so I will get 24x plus 24y plus 24z plus xy equal to 9xy. Shift that to that side, so I will get 8xy. Right, obviously I cancel the factor of 8, so I'll get 3x, 3y, 3z, and 8 will disappear. Right? Okay. Now I have an equation in x, y, z. Variable थोड़ी कम करें. अब ये z है यहाँ पे. Is there a relationship between x, y, and z? Yes, of course, because ABC is a right triangle. That means this square plus this square is equal to this square. So x square plus y square is equal to z square. I might be able to use this. I don't have square quantities. That means I have to square it up. But I'll be very smart about squaring it up, right? Because I don't want some terms to get cancelled. So what I'll do is, I will keep 3z lonely, and I'll shift these two that side. So xy minus 3x minus 3y. Why? Because when I square it up, some terms will get cancelled. Let's do. Square it up. So this is x square y square plus 9x square plus 9y square minus 6x square y plus 18xy minus 6xy square equal to 9z square, and put 9z square as 9x square plus 9xy square, which gets cancelled. That's fine, I did that. So cancel it out, this is equal to 0. Right? Also, xy is common, right? Take xy common and cancel it out because of course xy cannot be 0. So this becomes xy minus 6x plus 18 minus 6y equal to 0. Right? This is the equation. Now from here, I need to find out the value of x and y. Now I know that x and y are integers. Right? Maybe I can use that. Right? And I need the space. So what I'll do is I'll erase this because we don't need the diagram anymore now because I've found the equation. Right? I'll keep one. I will not erase this part because I forget it. So I have my equation xy minus 6x plus 18 minus 6y equal to 0. Right? From here, what I can do is I can put the value of x as integers like 1, 2, 3, get the corresponding integral value of y. But the question is, it becomes tedious to work in this sort of equation, right? Because two variables are getting involved. So what I'll do is, first of all, I will try to isolate one variable. Let me do that. So let me select the like term. So let me take y into x minus 6. Through this to that side, so I'll get 6x minus 18. Right? I can write y as 6x minus 18 divided by x minus 6. So put integral values of x and get the integral values of y. But the question will remain, where will I stop putting the values of x? Right? Because here it is a variable, here it is a variable. I have to put x in numerator also, denominator also, divide it and then check whether it is an integer or not. If I had variables in just one place, right, it would have been a little bit easier in just one place. So what I'll try to do is, I will try to get rid of this variable in the numerator. This is x minus 6. What I'll do is, I will write 6x minus 18 as 6x minus 36 plus 18. Think about it, why I did that. Why? Because x minus 6, here I have 6x minus 36. I will separate it out. 6x minus 36 by x minus 6 plus 18 divided by x minus 6. You can see, because if I take 6 common, this is 6 into x minus 6. This will get cancelled. I will get 6 plus 18 by x minus 6. This is my y. And since variable is in just one position, it is easy to see where to stop the process. Right? So let me see that. So this is the equation. I need the space, so I will erase this. Sorry about that. Right. So I have y is equal to 6 plus 18 by x minus 6. Right. Now, this thing has to be an integer because y is an integer. Now, if this has to be an integer, let me see what can the value of x can be. Can you put x as 1? Of course not. Negative ho jayega. So let's not do that. Can I put x as 2? No. I can see the first value that I can put. It cannot be 6. It has to be 7. Right? If x is 7, this becomes 1. So 18 by 1, which is 18. 18 plus 6, y will turn out to be 24. Right? So Pythagoras triplet 7, 24, z can be 25. So this is one such triangle. Right? Remember that it is a right triangle. Next, value of x that I can put, that is 8. This becomes 2. So 18 by 2, 9. 9 plus 6, 15. Y is 15. 8, 15. Pythagorean triplet, z is equal to 17. Okay, this also can be the triangle. Right? X equal to 3 can I put? No, not 3, 9. So this becomes 3, 18 by 3 becomes 6, 6 plus 6, 12, so y becomes 12, z will be 15. Done. X, can I put x as 10? No, because if I put 10, then that becomes 18 by 4, not an integer. Then 11, no. 12, yes. Let's see. If I put this as 12, this becomes 6, and this becomes 3, 6 plus 3, 9. Now mind it, x is 12, y is 9. Z will be 15. Right? This is the same triangle only. So we don't want this triangle. Repeat it. Right? Because these are all possible ones. Repeat the same code, दोबारा से count नहीं करेंगे, obviously. Right? Now, x 12 हो गया. Next would be x I can put as, I can put 13, 14. Can I put as 15? 15 minus 6, 9. 18 by 9, that is 2. Y will turn out to be 8. But 15, 8, 17. Already I have written it, so I cannot take this one. I cannot put x as 16, 17, so on, 20, 21. Maybe I can put x as 24. Cheating, really, but okay. Right? Now, if x is 24, this is 18, so 18 by 18, which is 1. Then y will turn out to be 7. 24, 7, 25. Already written, I do not want this. Right? Further on, if I put x as 25, mind that the denominator will become greater than 18. Right? It will become greater than 18, 18, 18. That means this will not be an integer. Now, if this is not an integer, how can y be the integer then? Right? That means my process will stop. These are the only 3 triangles possible. Now, I want sum of the smallest side length. Smallest side length, 7 here, 8 here, 9 here. Add it up and you will get the answer as 24. 24. 15 plus 9, 24? Yes. Which is the answer. With this, we are concluding the discussion of the test. Right? The answer key and the question paper obviously is there in the description box. So if you want to see it, you can see it. Now, if you have attempted this paper well, you have seen it. The main focus of this paper is how do you deal with questions when you get in paper? You'll get a brand new question, right? All you need to do is read the question well, understand what he's asking. Think about it. Okay, how can I go on about it? If I want number of order triplets, how can I find it? Maybe I can find out the number of ways. If symmetry is there, if he is asking this length, what can I do to that length? Maybe I can find the angle. Maybe midpoint is there, midpoint theorem is there, right? So just read the question carefully and try to apply the concepts that you already know. And also, since it is an integer type, that means your calculation and concentration has to be on point, which is very important. If you get the concept, but if you do the calculation wrong, the question is gone. You will not get the marks for it. So you have to be careful. Anyway, so we have another test on Sunday. So I will see you in the next test discussion.